Hi, welcome to my channel. In this video, we want to find the real solutions of the following equation. X minus 2 over x plus 1 to the power of 5 plus 2x plus 5 over x plus 1 to the power of 5 equals 393. First, we make the substitutions. A equals x minus 2 over x plus 1 and b equals 2x plus 5 over x plus 1. Thus, we have a to the power of 5 plus b to the power of 5 equals 393. The sum of a and b gives us 3x plus 3 over x plus 1, which equals 3. Next, we take the fifth power of both sides of the equation, a plus b equals 3. The left-hand side becomes a to the power of 5 plus 5a to the power of 4b plus 10a cubed b squared plus 10a squared b cubed plus 5a b to the power of 4 plus b to the power of 5, while the right hand side is 243. Following this, we group a to the power of 5 with b to the power of 5, 5a to the power of 4b with 5ab to the power of 4, and 10a cubed b squared with 10a squared b cubed. After factoring out 5ab from the terms 5a to the power of 4b and 5ab to the power of 4 and 10a squared b squared from the terms 10a cubed b squared and 10a squared b cubed. We then substitute a to the power of 5 plus b to the power of 5 equals 393 and a plus b equals 3 into the equation. The coefficient of a squared b squared is 10 times 3, which is 30. After that, we subtract 243 from both sides of the equation, and then divide by 5. And lastly, rearrange to obtain 6a squared b squared plus ab times a cubed plus b cubed plus 30 equals 0. Before we can proceed, we need to evaluate a cubed plus b cubed. To do that, we again work with a plus b equals 3. Cubing both sides of the equation, we obtain a cubed plus 3a squared b plus 3ab squared plus b cubed equals 27. After factoring out 3ab from the terms 3a squared b plus 3ab squared, we substitute a plus b equals 3 into the equation to obtain a cubed plus 9ab plus b cubed equals 27. Subtracting 9ab from both sides of the equation then gives us a cubed plus b cubed equals 27 minus 9ab. Substituting our expression for a cubed plus b cubed into the previous equation, and then combining like terms, and lastly dividing by minus 3, gives us a squared b squared minus 9ab minus 10 equals 0. Let's solve this equation by factorization. Writing minus 9ab as ab minus 10ab, we obtain ab times ab plus 1 minus 10 times ab plus 1. Since ab plus 1 is common to these two terms, the polynomial factorizes as ab minus 10 times ab plus 1. Therefore, we have ab equals 10 or ab equals minus 1. When ab equals 10, we have b equals 10 over a. Substituting this into the equation a plus b equals 3, we get a plus 10 over a equals 3. Multiplying by a on both sides of the equation to clear the denominator, and then rearranging, we obtain a quadratic equation a squared minus 3a plus 10 equals 0. Since the discriminant is negative, the equation has no real solutions. When ab equals minus 1, we have b equals minus 1 over a. Thus, we obtain a minus 1 over a equals 3. Again, we multiply by a to clear the denominator, and then rearrange to obtain a squared minus 3a minus 1 equals 0. Recalling the quadratic formula, with alpha equals 1, beta equals minus 3, and gamma equals minus 1, we thus have a equals 3 plus square root 13 over 2, or 3 minus square root 13 over 2. Since a equals x minus 2 over x plus 1, let's try to express x in terms of a. To do that, we first multiply by x plus 1 to clear the denominator. Next, move x to the left side and a to the right side. Then we factor the left side, and divide by a minus 1, to obtain x equals minus a plus 2 over a minus 1. Substituting a equals 3 plus square root 13 over 2 into the expression for x, We obtain after some algebraic manipulation s equals -1 plus square root 13 over 2. Substituting a equals 3 minus square root 13 over 2 gives us s equals -1 minus square root 13 over 2. Therefore, the solutions to our original equation are -1 plus square root 13 over 2 and -1 minus square root 13 over 2. As an exercise, try to solve this equation and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.